Hey everyone, in this video we're finally going to get back to orientation warping, and I've figured things out. It's working properly in my testing project, and we're going to implement it, or well, begin implementing it in this video. It's a bit of a long process, so I'm splitting this video into two parts, and in the first part we'll be getting our project set up and ready to plug our orientation warping nodes in and do some of the extra math we need to do to get around the hemisphere issue where the angle of 0 and 360 is the same and negative 180 and 180 is the same, but the computer doesn't understand that, and that leads to issues. And getting our orientation warping nodes plugged in and all of that setup will be in part 2. This part will just be covering everything we need to cover to get the project set up and ready, getting our stops and starts fully worked in for our backward animation, that kind of stuff. And so I don't want to make this intro too much longer, so without further ado, let's just get into it. So right now we have a character that can start and stop walking going in one direction, just well, forward. And our character turns in the direction of their velocity, and that's pretty much all there is here. And now we're going to add orientation warping back into this project. First, we're going to open our character. We're going to go to character movement, and I'm going to search orient, and there's this option here called orient rotation to movement. I'll uncheck that. I'll compile and save, and now our character doesn't face the direction. And now our character no longer faces the direction of our movement. But if we move the camera around, it doesn't turn the character. And so we need to go into our character again, select BPDM character self. And if we just search yaw and tick use controller rotation, and tick use controller rotation yaw once more, we rotate with the controller again. So now, functionally with character movement, everything is here. We just need our character to be able to walk in different directions using orientation warping inside of our animation blueprint. And to do that, we have to be able to tell when the character is going in different directions, such as forward, right, backward, and left. And we can figure that out using our direction variable, which we actually, if you've been doing the same print string things that I have, which I usually just will throw them into debug something, maybe even off screen, and they sort of show up because I cut that out of the video. So if we go over to our animation blueprint, to our event graph, right where we are setting, where are we setting our direction at? Over here. I'll need to do some organization, separate some stuff out, and collapse it all down to some different nodes, that kind of stuff, but that can wait until we're done building the system, I think. But here we're setting our direction, and I'm just printing this as a string. I have duration set to 0. That's important because it's happening every tick. And you'll see this second variable here. The second value here, and it's 0 when we're going forward, goes between 180 and negative 180 when we're going backward, 90 when we're going right, negative 90 when we're going left. And we can use this to determine our to determine which of the 4 different directions the character is moving in. And we're going to refer to those 4 different directions as cardinal directions. Because classically, what Epic Games did with distance matching, instead of calling it forward, right, backward, and left, they called it north, east, south, and west. I prefer forward, backward, left, and right, but that's just personal preference. So we're going to name this integer variable cardinal direction, and to calculate it, we are going to test if the direction is between different values. Because if the character, think about using a controller, and if the character is going right, but you're not perfectly pushing the joystick to the right, and it's off just a little bit, the character is still going right. And so we're going to have 90 degrees in each direction, so that if I pull up paint here, you have a circle. This is our 0 to 360, and we essentially have a very bad cross through it like this. And in this cross, this is our forward, this is our right, this is our backward, and this is our left. And so we're just taking these 90-degree sections. This would be from -45 to 45, that is forward, 45 to 135, that is right. One backward is a bit different, so we'll come back to that. -45 to -135, and then backward we're not getting in between two variables, because this is -135 to -180 and 135 to 180. It's going to either be less than -135 or greater than 135. So now I'm going to implement that logic. I'm going to drag out and get the direction variable. I'm going to get a less than or equal to and a greater than. And the reason I've chosen these two nodes is because if we, let's say, let me show you through example. I'm going to duplicate this, and so we have our -45, actually we have our less than or equal to 45 or greater than -45. And that's going to be forward. And when we get to left, we want this to be, left is, if you remember, less than or equal to -45 and greater than -135. And so we have -45 on here twice. And if this was just a less than, then if you're exactly on 45, it won't know what to do. And if both of these were, if this was less than or equal to or greater than or equal, and this was also greater than or equal to, and then you have two conditions where -45 can give you two different directions, and that can cause issues. It can flip back and forth between directions. It'll cause issues down the line. And that is why I'm using a less than or equal to and a greater than for each direction. But to keep things in the order of the integer, which is going to be 0, 1, 2, 3, where 0 is forward, 1 is right, 2 is backward, and 3 is left, I'm going to stay in that order here with this logic. So left is going to be the last one we do. So after forward, I'm duplicating it with Control W. We want to get right, which is less than or equal to 135 or greater than 45. I'm going to get backward, which is less than or equal to -135 or greater than 135. And we have left here. So I'm going to get an AND node, and I'm going to plug it in with our forward, less than or equal to, and greater than node, and that'll just give us true if the direction values in between these. I can do the same thing with right and left, but backward has to be an OR, because -135 doesn't go to 135 on the bottom half of the circle here. It goes around like this, and so if we use an OR, well, things won't really work out. So I'm sorry, if we use an and, things won't really work out. We're using an or so that things do work out. And now we need a branch. And so for every tick, we're going to go through these, we're going to evaluate the value of a direction with the criteria for each cardinal direction, and we're going to then, one after the other, if it isn't forward, we're going to test if it's right. If it isn't right, we're going to test if it's backward, and if it isn't backward, we're going to test if it is left. So the false of each branch goes into the subsequent branches first input here. The input for our first branch will just come straight from our set direction node, and we can delete our print direction node. So now if this is true, we need to set our cardinal direction. So I'm going to drag that out with just Alt-click to get an automatic set. I'm going to duplicate it with Control-W and plug in the true of all these nodes into the cardinal direction. And now for forward, it's 0, right is 1, backward is 2, and left is 3. I'm gonna go ahead and compile that and save, if it crashes, we don't lose all this, and it rarely ever crashes, but I like being safe. So now to demonstrate this, I'm going to drag off from direction, and I'm going to get a sequence node. Then 0 will automatically get plugged into the branch, and then within 1, I'm just going to get a print string, and I'm going to get cardinal direction, and plug that into the end string. I'm going to set the duration to 0. Actually, I'm going to get a little bit more fancy. I'm going to drag out from end string, and I'm going to get select. And that will give me this select node. I'll plug cardinal direction as an index. I'm going to right click, and I'm going to add 2 more pins. 0 is F, 1 is R, 2 is B, and 3 is L. And the text color is going to be green, so we can tell it apart from the others at a glance. Now if we play, we're going forward, we're going right, we're going backward, we're going left. And so if you have this working here and you are printing the correct letters, we're ready to move on to the next part of the video, which is coming up right now. Okay, so we have our basic direction calculation. Now we need to change some of our animation blueprint. I'm going to open up grounded locomotion, and I am going to drag out from entry, and I'm going to add a state, and I'm going to name this Locomotion. And the reason I'm making a separate state over here will be explained. But for now, just know that we're dragging off from entry and creating a new state, and we're not connecting it to any of this. We're going to go into Locomotion, drag out from output animation pose, and we're going to get blend poses by int. I'm going to add 2 blend pins, and I'm going to plug in cardinal direction as the active child index. Now we need some now. And here we're going to have forward. Here we're going to have, okay, so in blend pose 0 is going to be forward, blend pose 1 is going to be right, blend pose 2 is going to be backward, and blend pose 3 is going to be left. And we could just plug in our running loops for these 3 blend poses, and then between our running loops and our blend poses, put our orientation nodes in, our orientation warping nodes, I mean. But then what about starts and stops? When our character starts, they're not going to use orientation warping, and when they stop, they're not going to use orientation warping. And that is an issue. So instead, we're going to have a state machine for each direction containing our start animation, our loop animation, and our stop animation. And so that entire state machine can be plugged into the orientation warping node. And that is why we have this locomotion state separate from all of this, because I am going to copy this. I'm going to go into locomotion. I'm going to create a new state machine, and I'm going to name it FWD for forward. I'm going to double click to enter it, and I'm going to paste our copied grouping of states, and I'm going to plug entry into idle. And now I've made some changes to some of the timing for the blends, and I want to do that in here before we copy this forward state for our other directions. Idle to starting is going to have a duration of 0.2. Starting to running is going to have a duration of 0. Running to stopping is going to have a duration of 0.2, and stopping to idle is going to have a duration of 0.2. Now, inside of starting, we have our start time, and we have this evaluate in run start f anim, and we also have our old movement state from when we first, for my first attempt at implementing orientation warping. We don't need it, we can delete it. In running, we have our play in run f anim, which is correct. And in stopping, we have our run stop f left up and our run stop f right up. That is also correct. And so we can leave this forward state, go back into our locomotion state, Control W to duplicate it, and rename it from forward 1 to RT for right. I'll go ahead and plug this into blend pose 0 and blend pose 1. And we're going to be using orientation warping to turn the forward running animation into a right running animation. Just a second orientation warping node with a value like, I think, 90 put in there. Maybe it's a negative 90, I'm not sure. I'll check when we get to that point. Anyway, so backward, that's next. We're going to duplicate this state, but first we need to set up starting for our backward direction, because we haven't done that. We just set up our starting for our forward direction. And so we also need to get starting and the backward direction set up for our stopping as well, because we pulled that out. So we're going to duplicate this entire section that's plugged into set stop time. But instead of using in run stop F right up, we're going to use run stop B right up in our duplicated select node. We're going to do the same for left up, change it to run stop B left up. And now we're going to take our value from our top get curve time for going forward. We're going to drag out from it, and we're going to get a select float node. We're going to plug in our get curve time for backward into B. Get curve time for forward was already automatically put into A. And now we're just going to get our cardinal direction variable. We're going to drag out from that, and if it's less than 2, I'm sorry, if it is less than or equal to 2, we're going to pick A, which is forward, because I'm sorry, it's less than 2. I forgot 0 and how we're using that. So I was thinking 1 is forward, 2 is right. No. So less than 2 is either 0 or 1, which is forward or right, and we're going to be using the forward animation for those two directions, and so that will give us our forward animation get curve time. So we'll plug that up into stop time. And now we're going to do something very similar over here for our get curve time for our starting. We're going to duplicate this section, and we're going to change in run start F to in run start B. And I'm going to duplicate the select float and the logic. I'm going to and then plug return value into start time. And I'm also going to get rid of this start time as we don't need it. So now we have our logic for getting our stop time and start time for both the forward and backward animations. So I'll go back into Locomotion, I'll duplicate forward with Control W and change it to backward. Now, in starting, we want to evaluate in run start B anim. For running, we want to play in run B anim. And for stopping and left up, we want to evaluate run stop B left up, and for right up we want to evaluate run stop B right up. Can plug backward into blend pose 2, duplicate it once more, plug it into blend pose 3, and name it LT for left. Compile and save, and if we play, walking forward works, but walking left and backward doesn't, and our character doesn't turn yet, and that's because we haven't set up our orientation warping nodes. And the reason our character isn't working walking left or backward is because we haven't set up the settings correctly in some of the animations that we're using here. So let's go into our animations and let's check all of these. Enable root motion should be on for in run B anim loop. In run stop B should have enable root motion turned on and curve compression settings set to uniform indexable. The same for run stop right up, run stop B right up, enable root motion, and then uniform indexable curve compression. And run start B, root motion enabled, uniform indexable curve compression. And now we are still not working when we're going backwards. Our stop is working, but our start isn't. So in run start B anim, let's open it up, and we need our distance curves. I forgot. So we're going to add our start distance curve and save, and let me check our run stop B animation. Those both have distance curves. So now, if we walk backward, we play our starting animation and our stopping animation. And so we don't have the orientation warping here yet, and that is going to be in the next video, the third video on orientation warping in this distance matching series. And that is because we can't just plug in our nodes and plug in some variables. There's some somewhat kind of complex math that we have to do to solve some hemisphere issues when transferring from directions like that we're in a positive to a negative hemisphere of our circle, like our positive 0 to 180 to our negative 0 to 180. And to do that, we have to implement some extra math and logic. And so that is why I'm splitting this up into 2 parts. Everything is ready in this part for orientation warping to be added in, and in the next part, we're going to add it in. And I'll see you all in that video. I guess I'll go ahead and roll the outro. Alright everyone, I hope you enjoyed the video, and if you did, be sure to like and subscribe. More videos are coming. Thanks for watching, and I'll see you in the next video.